I think we shall start the event, if that's okay with you guys. So yeah, welcome to everyone attending the event this evening. We're looking forward to getting some more of you join in a sec, but we are live on Facebook. So share with your friends, tell your friends about this, get them to join. It's not too late. We are really excited to bring to you our fourth webinar of the XR in series. This is XR in engineering, and we have it's mainly around the areas of Unity. So we have two really incredible speakers with us today from Unity Technologies. So yeah, welcome to you guys. I'll introduce you in a sec. So just a couple notices. If all the attendees wouldn't mind keeping their microphones muted and their cameras off, it just helps with smoothness of the event and make sure that the connectivity is on point. The event will be recorded and will be uploaded onto YouTube. We have just uploaded our last 3 webinars onto YouTube as well. So if you missed them, do check them out. We had XR in medicine and surgery, XR in business and enterprise, and XR in radiology last week. So really cool events, check them out. So yeah, I'm gonna kick off by introducing our 2 speakers. So we have with us Andy Keetch, who is account executive for Unity. He has a lot of experience in understanding and communicating the impact and power of Unity and how it impacts the immersive world. Andy is also a Leeds University graduate, so we're really excited to hear a bit about how he went from uni to Unity. And also with us is Fred Moreau, who is the solutions engineer for Unity. He has a collection of technical skills and expertise in Unity technology and just overall great technical skills and a real eye for design. And he helps lead projects and development for projects. He helps these teams, teams through the creative process of developing projects. That was a bit wordy for me, sorry about that. So yeah, welcome to both of you. We're really looking forward to hearing about how XR is used and applied within Unity and within the world of engineering. So I will hand over to you guys, and yeah, thank you.
Great, thanks very much. Big fan of the from uni to Unity. That was nice, liked it, smooth. So Fred and I are going to cover off a few things that we've been working on as Unity. I'm going to give a very brief intro to Unity for those of you that may only know us as a games engine or may have only heard of us as a games engine. So we'll cover that off. But just briefly, so I work in our sales function. And I focus on clients who are in the architectural, engineering and construction spaces mostly, although I also work with some automotive, some transportation, some manufacturing companies. So really trying to help people understand what technology is available, how they can use that technology, and then the benefits of using it, from streamlining workflows to understanding different use cases to understanding how actually there are new, different, better ways of doing stuff across those various sectors. And so I'm definitely not a technical person. My role is very much about those business challenges, those organizational challenges, and the kind of like not the fluffy side, that's definitely the wrong word, but very much more on the like, cool, here's a problem, here's how we fix it. Whereas Fred, who can do his own introduction because he'll do it much better than me, Fred's role is very much the technical side. So Fred, do you just want to give a quick overview of what your background as well?
Yes, for sure. So I've been with Unity for about a year and a half now. And prior to joining Unity, I used to work as a coach and also as an instructor. So helping people learn how to use Unity and also organize themselves and drive and run a innovation project, especially around lean project management and agile principles. I've also had my own company in the past, and so I actually did work as a programmer and as a tech artist also prior to that. So my key role is to make sure that people who want to learn get the learning curve wherever they stand and get to grow.
Cool. So we're going to cover hopefully some of the more interesting elements of what we're working on at Unity. We've got a sneak peek of our brand new product, which is launching this evening, as well as another couple of tools and partners that we work with. We'll cover off some of the use cases around VR and AR and how we see that working within the industrial sector. I am going to, so my role is sales, so I will always default to sounding quite salesy. Please don't be offended. I am not trying to get you to buy anything. It's just habit now. And we're also going to try and keep this fairly jargon free, although I'm assuming you guys are all pretty technical, but feel free to fire questions at us. I know there's Q&A at the end, but if you have any questions you want to ask or anything you're not sure of, just throw it in the chat and we will do it as best we can to answer those. Oh. Great. So, so little bit of background. Unity started in 2004 with a group of friends trying to make an excellent game. It's called Google. I'm going to go ahead and assume nobody knows what it is because it wasn't nicely, it wasn't a commercial success. The game tanked. But what the guys learned from making that game is failure's fine. Like Rovio took 90 attempts to get to something like Angry Birds, so that's okay. Like you don't have to nail it on your first go. But also what they saw was like the hardest part of making a game isn't the idea, it isn't the characters, it's actually about the engine, the physics, the world behind it. So they saw value in that game development tool they've created, and they shifted the company's focus away from games to creating an engine for other developers. The whole focus there was around this idea of trying to like democratize game development, to try and make it a little bit easier for other people to do 2 and 3D games, to make that interactive content more accessible, and also to just try and focus on stuff being platform agnostic as well. So not getting tied into consoles, not getting tied into a particular platform, but to try and keep it as agnostic as possible. Oh. So what that meant was, by the time the iPhone launched in 2007, we were particularly well placed to take advantage of that. And I think we were one of the very first engines that had like full access to iOS and able to create stuff. So games like Pokemon Go, that's built on Unity, which is amazing. So it's really, really good for us, right? And it just means that there's a lot of people that are now able to do these type of AR environments, but also beautiful platform games. Like we've talked about, one of my favorite mobile games is Pokemon Go. Played that quite a lot, but there's also like a lot of little games which are just neat, lightweight stuff which Unity allows you to do. But we've also been able to do those bigger games as well. So this year we helped the guys at Mediatonic release Fall Guys, which is nuts. This had like 1.5 million players, in under 24 hours. It was ridiculously successful. But these are an indie little studio. They got in there quick. They were able to do this stuff, and they were able to make it happen because our focus was very much on let's make this technology accessible. Let's make it easy for people to do. That Unity is built in C#, which a lot of developers know how to use, and it's a fairly easy language to pick up, which is great. And that was really where our focus was for a very long time. But over the probably last 8 to 10 years, there has been a realization that actually, although we've built a games engine, what we've actually built is a real-time 3D engine that enables people to solve problems, to create environments, and to build solutions. So you don't need to focus on games. You can look at different areas to build work out. So this idea of like real-world applications at scale and being able to deliver immersive experiences, interactive experiences, and stuff that really helps people make a vision come true. Cool, you don't have to do games to do that. There's loads of different ways of doing it. So I've put together this really disgusting slide, which you absolutely don't have to read, but it's here because it's useful, right? So when we talk about real-time 3D, what we're saying is it's fully interactive models. It's environments built in virtual worlds that can be rendered faster than a blink of an eye. We don't have to worry about render farms anymore. We don't have to worry about, oh, how do I get that system from there to there? Because there are the pipelines and the interactivity between these systems exist. So you can draw your model in CAD, in Revit, in whatever, and you can import it into a real-time 3D engine to enable you to build those immersive experiences. So that is a disgusting slide. You can read it at your leisure later, but I think there's probably a more visual way of doing this, which is our a little showcase of some of the work that we've been doing. There is sound on this, but it won't play because I've got headphones on. So we'll share the deck. You can listen to some of it. But what we're talking about here is looking at using this technology to help build solutions in a quicker, easier, better, more interactive way for different industries and different needs. So if you look at something like automotive, they were very quick to adopt this technology. We've also been looking at different solutions around simulation. So can I run a test multiple times within a system without having to use people to do it? Can I see if a design is going to work in the real world? Yeah, you can. You can put the physics in place. You can understand how that works, and you can understand how your design is going to fit in the physical space. But you can also use it for training. You can also use it to make money with, right? So there's various different ways of taking this technology and making the most of it. So we will talk a little bit about automotive, but really where we want to focus is just the use cases for these tools. So look at how people are doing stuff, look at training, look at interactivity, look at construction, look at how we build now. So the other thing that is really interesting, so obviously we're a business, we will definitely say that Unity is the solution to all of your problems. Definitely come and talk to us, but that isn't how you grow. You grow by understanding the market that you're playing in. And we commissioned Forrester this time last year. So Forrester Consulting, we asked them to understand what the market was like for AR, VR, real-time 3D, to really understand, are we pursuing the right path? And we were, I mean, I first saw these numbers and I assumed they were just sort of marketing spin and made up, but I've been reassured that they are true. And if you look at this, you've got people who are looking at, like 95% of the people we surveyed were saying that this technology is invaluable for design and prototyping. And when you think about it, if you wanted to build a helicopter, a new model of a helicopter, you used to have to physically build that model of a helicopter. You don't have to do that anymore. You can do it in real-time 3D. You can build the physics behind it to understand how it's going to work and how it's going to operate, and you can make changes on the fly. If you look at it from a field service perspective, if you've got engineers out in the field and you want to understand if they're working with a new piece of kit, typically that would be a lot of training or that would be a lot of hand-holding, but you can use AR to enable your field service engineers to get to a site. You can talk to them, you can highlight the parts that they need to interact with using all this technology. And again, that's about streamlining and making things safer. So there's a few other things that we'll cover off as case studies as we go through, but that's just as a little bit of a starting point. And then for us, we know it's great technology. We know people want it. What is driving the adoption of this technology? And there's a couple of things in here which I think are important to point out. So there are industries where the workforce are definitely not digital natives. They are definitely older. And they're using technologies like pencils and paper. And that works and that's cool. But it's not how you attract new people into your business. You need to understand that if you want to be successful, you need to look at this new technology. So there's a demand there for easy to adapt, easy to use, easy to pick up technologies. Sustainability, absolutely, we should be focused on that. And if we can remove the need for business travel, if we can remove the need for resource-heavy prototyping, if we can remove the need for wasteful processes by understanding how things work, that's amazing. And as technology gets faster, better, more intuitive, more easy to use, we can start to see how people are picking that up. However, the thing that has happened this year and the big thing that is going to shape the future has been COVID-19. And there are digital transformation agencies and consultancies who have been banging on about this stuff for years, and they have had very little impact. And it turns out that a global pandemic that stops people from being able to see each other is the fastest way to drive technology adoption, because you had to find different solutions to work. You had to find different routes to market. You had to find different ways to keep your workforce safe. And using this type of technology has absolutely allowed that to happen. So it's I'm a fairly optimistic guy, so looking on the bright side of COVID, it's been pretty good from that perspective. It's also been really interesting to see how it's forced companies that have been against things like working from home or against things like different approaches to technology have had to adapt, and that's not necessarily going to change when we've had the vaccine and when we can get back to work. I think these remote workforces are here to stay, which is a good thing in my opinion. So what we try to look at and how we talk about stuff within the industrial space within Unity is very much around these core pillars of create, build, and monetize, because that's how businesses want to focus on stuff. So when we talk about design and virtual prototyping, we've worked with Bell Aircraft in America and helping them design helicopters. We've worked with So when it comes to things like engineering and simulation, we work with Volvo on the development of their autonomous vehicle, and we've helped them very quickly get to the point where their cars are incredibly safe because they can identify hazards, they can identify what different things look like and how to react to it. We have a wonderful video that also involves a 3D rendered moose, which I think is the first time I've ever seen that in a presentation, which is pretty cool. When it comes to things like production and construction, we've worked with Skanska, one of the biggest construction firms in the world, on training their staff. So one of the key drivers for a lot of construction firms is driving down workplace injuries. Like, the nature of the work, it is a dangerous environment to work in. If we can do anything to reduce the numbers of injuries in that space, then that is only a good thing. So using VR training, you are able to help people who have to work on site use autonomous vehicles, use drones for surveying. We can use that technology to help people understand the right way to put systems together when they're in there. So it's just trying to streamline these processes. We'll talk about sales and marketing later, because that's very much where we are seeing new growth. So for big industries, everything used to be based on going to massive faceless conference centers, usually in Birmingham, to get walked around and shown new products, and that can't happen this year. So there are new routes to market that we've been looking at, which are quite interesting. And again, when it comes to things like service and usage, I talked about AR assisted maintenance, but if you imagine you have a recycling plant and you need someone to be able to find their way to the Tetra Pak squasher and then work out what's wrong with that system, you can have one engineer guide a service person to that machine, talk them through it, use AR to highlight the elements that they need to do. And again, it just speeds up those repair processes. So for context around that, this is how you used to design a prototype car. That's clay. You used to shape it, carve it, stick it together like that. And if you wanted to make any changes, it was literally back to the carving block to edit those models and to make those changes. Now, this is a design review for Audi. So you've got your team in VR looking at your model. They can see how it operates. They can see how it works. They can make the changes. They're all discussing the same thing, but they're not working around a physical model. So if they need to make any changes, it's as simple as making those edits, and then those changes are reflected in that model that they're looking at. So it's quicker, it's more efficient, and it's a lot less resource heavy. If we look at around these engineering solutions, so this is just a big CAD model that shows, okay, cool, this is what this bridge will look like. But actually, if you take those models and you push it into a real-time 3D engine, you get this type of view. So not only do you understand how it's going to fit within your physical space, but you can also look at how it's going to work, how it flows. Does it fit through the ports that it needs to fit through? Are there any measurements that are off that might cause clashes? Because you can put physics into these models to show you those challenges. That's the Brisbane flood protection bridge. And again, it's in situ. You can see how it works. One of the other areas that used to be incredibly intensive on people was around simulation and games testing. So you'd build a game and you would go and bug test it by hiring a bunch of people to sit and play your game for hours at end, and then see if they could complete it, see if there are any problems. They would come back, they would feed anything they found back to you, you'd make edits, you'd repeat the process again. It works, but it's incredibly slow and it's incredibly labor intensive. So using AI, we're now able to streamline that process, and you can feed your model into the simulation engines, and they can run hundreds of thousands of simulations incredibly quickly. So you can very, very quickly work out what the problems are going to be or how your technology is going to react to that. So again, what we're talking about here is using this technology that come from games and taking it to apply it to a real world situation. So this model is about an autonomous vehicle and how it interacts with different elements around a city. And then we talked about building, but the other element of building is you want to see a plan, it's on paper. This is what building sites used to look like. It was men in suits and high-vis jackets pointing at stuff on paper. Now we've got to a position where you can grab your iPad and you can do a one-to-one AR model from your iPad. So if you want to see what your building is going to look like on that particular lot, you can do it. You can push your model into a tool that we have called Reflect, and you can see what your building is going to look like in space. That gives you a real sense of space, of scale, of how systems are going to work. There's another element to that as well, which is you can also include things like, okay, my model is this big, so if I need to bring on 200 cement trucks a day, how do I make that happen? Can I feed that through? How is the workflow going to do this? You can combine your simulation about bringing in trucks with your scale model to understand the space that's there. So what we're trying to do is remove as many pinch points and problems as we possibly can before they're actual problems. And training. So a lot of people who have done any kind of technical training, it's done in classrooms, in workshops. You have to read a manual and then you get given a spanner and a thing to try and fix, and off you pop. And it works, and it means taking all of your field service engineers out of the field into a room to get it done. However, on the job training now using AR and VR is so much quicker. It's safer, it's easier. So here you can see an example of someone trying to understand which way to test flow within a system. So she's watching a video on her, she's got AR video up so she can understand what's going on. She can see the instructions, she can see how far that she has to move the tools to make this make the equipment work. And it's all there. All of the additional information can be piped straight into that headset so she can make those changes that she needs to at the same time. So again, taking the stuff that you would do, and this is effectively Pokemon Go for boring people now, because you're getting to grab those solutions and grab those situations and do stuff with it. And that's, again, a bit of a game changer from a safety, a speed, and an interest perspective for us. So that's just kind of a few examples. And then one of the other things that we are very guilty of talking about is the fact that we have got, like, it's effectively, what's your problem? Absolutely, we can solve it for you. Like, if you wanted, we could sit here and we could spend 2.5 hours talking about all of the various different products, approaches, different ways of doing stuff, different things that we have to do it with. So we've got PaceLab Weaver. If you wanted to do VR training, we can do drag and drop training for you. If you wanted to understand the analytics behind your games engine, we can do that. Do you want to do content distribution networks? We've got it. You know, that there is a wealth of information that we have and a load of different approaches that we have. I think that if you've not had a play around on the Unity website, we allow demos of pretty much everything that we do, because the best way to learn is to play with stuff. But we aren't going to go through all that, because I mean, it'll be tedious, but and we don't have enough time for it. So what we're going to do is I'm going to hand over to Fred, who is going to show you a couple of these tools that are very specifically useful for the areas that we're focusing on. So we're going to talk about AR Foundation. And we'll also talk about Mars, which is an application that we've built to help mixed augmented reality simulation within the tool. We'll talk about Interact, which is our point cloud scanner and digital twin creation, which gives you real world physics. And then we'll also talk about Forma, which is our new product at the end. Cool, all good, Fred?
Yes, all good. I was trying to get a hold of the unmute button, which somehow disappeared. All right, so actually, I'm glad that I get to take it over from that slide that you just showed. As I guess that, you know, the first time that you get into a system or a software or anything, there's usually two different kind of reactions that you can get in front of you know, that many features, that many solutions. You can be overwhelmed or excited about, you know, everything. And I guess that the proper reaction is probably to be comforted in the idea that you don't need to know all, like, you don't need to know every of that to get started, but you can be assured that if you need at some point to do something that makes sense in the field of what you want to do with Unity, there are very good chances that we already have a solution or a service to help you in doing it. The motto of Unity has always been to democratize originally video game development, but we could also just say real-time 3D or interactive 3D development. And by democratizing, it's not just about making things available at a lower cost than what it used to cost. Because yes, like if you make the sum of all that you have instead of a Unity Pro license nowadays, that used to cost you like $1 million or €1 million or £1 million like a decade ago. And Unity's played like a real major role into democratizing this in that sense. But it's mostly, in my opinion, it's mostly about democratizing it by making it available and making it easy to use. Like prior to using Unity, if you wanted to say have autonomous characters walking around in a video game, then you would have had to not only just get a video game engine or a 3D game engine, but you would also have had to take a side, like a middleware, third-party middleware for AI, for artificial intelligence, or nav mesh navigation of those 3D characters. And then you would have had also to make those two work together. So that was a lot of effort to understand what you're doing, what you need to do, what you need to do it, then what you need to buy and how you do it, and then patch it all together to make it work. So not only just Unity did provide all of that in one single environment, but they also made it available so that and accessible through training and proper documentation, so that everyone can understand the basics of everything. So surely it does take still some engineering and some thinking to deliver. There's always the 80-20% rule, but we really deliver the 80% at 20% of the time and the effort and the cost of understanding something right out of the box. And then what you make of it is then yours to define and to craft. So with that being said, Unity has, like, to end this point, a tremendous amount of features, solutions, and even products now to help developers and users take advantage of real-time 3D, which is the generic naming of what we aim to help you do. One of them, and especially around XR, because XR is one of the big buzzword nowadays. And prior to joining Unity, in the past, I've had to actually develop a few XR, AR experiences myself with Unity. Way back then, we didn't have like anything inside of Unity but a few plugins to do it. And I've come to realize that XR is not just a technology. XR is really like a recipe. So it's made of ingredients, and ingredients like technological ingredients, but also semantical ingredients as to what does that mean to a user to take a phone and point it at an environment and get to see some mixed content, like mixing with the existing environment, and what is the story that we want to tell around that experience? What is the outcome that we expect of that experience? Do we want people to understand better so that they can take better decision? Thinking of, stakeholders, for example, trying to understand how the decisions were made amongst the engineerings or architects or civil engineers. Then how do you support, how do you back your decisions, how do you explain them to stakeholders who are not subject matter experts? That is one of the key goals that we want to use those kind of technologies for. Helping people get trained, same deal. We want to get someone who does not know something, and we want to help them know it better, know it faster, and have like a better understanding of the whys without having to tell them to read like collections of books before they can take a decision or operate the machinery. So with this in mind, I know that AR in general has been a very complicated topic because it relies, because of a few things actually. One, it's that it relies on physical hardware that is either a phone or a headset that you usually have to deploy to so that you can get to test the experience. And B, it also relies on the environment, right? Because if you're in just like in a white room with nothing, then you cannot test your experience properly in the real world conditions. And these are the things that we want to address with a few specific solutions. And also because there's so many solutions out there and so many APIs. So if you want to do an AR experience that works on both iOS and Android, then on iOS, you have to rely on ARKit from Apple that takes advantage of all the hardware that you have at your disposal on an iPhone or iPad. Then if you want to do this on Android, then you have to take advantage of ARCore. Probably 90–95% of the features are the same. They're all able to track images. They're all able to detect planes, to detect occlusion, to do all that. But it's the same thing, but they all do it in a slightly different way that makes for a developer a bit of a nightmare to be able to say, okay, I want to do this experience, and then I want it to work on all the hardware. So usually what people would do so far is that they would usually create their application on one of the two systems. Usually they would do it on iOS because it was a bigger market sometimes because it was just harder, and they would just do it on one of the two, and then they would outsource the replication on the other on the other platform to another company. What we've done with AR Foundation, it's the idea of AR Foundation is to have an abstraction layer between the different APIs and the different hardwares and what you want to do of them as a developer. So say you want to create an experience where you detect a plane so that you can lay out like 3D objects on the plane, then you don't have to deal with how do I do this on Android and how do I do that then on iOS. You simply say, as a developer, I want to detect a plane using AR, and then the abstraction allows you to build, because Unity is a multi-platform system, so you can keep one project, and that one project will be able to be built for all the platforms that we support. So including gaming consoles, PCs, WebGL, you name it. So basically, we've taken the primary AR platforms that are iOS, Android, and also Magic Leap and HoloLens. More will come, and the idea of that abstraction layer is that we can easily then just add subsystems to this based on what they support. So as a developer, you no longer have to deal with what is the hardware I'm running on, what is it capable of, how do I do plane detection, image detection, QR code reading, all of that stuff is done and is available to you as a developer with a very high level abstraction. So you can build your app on top of AR Foundation and simply focus on the experience that you want to bring to the end user instead of having to focus on the latest versions, especially that all of those tech solutions, they evolve very rapidly. So from a version to the next, they keep racing each other on feature X and Y. So as one changes, then you have to update everything. So there you no longer have to do to worry about that, because we're on the edge. We're working in partnership with those developers and hardware manufacturers, API developers, and we provide you with that abstract top layer that you interact with and create your experience out of without having to worry about what's happening under the hood. So that also allows you to create an experience that scales, because especially when you want to build and deliver an experience, you certainly not want to limit your audience to whoever has the latest iPhone, right? Because otherwise that really narrows it down to a very small market. So you want to have something that is scalable. So you want to be able to take advantage of the latest tech, yet you want to be compatible with a tech that is like 5 years old or something. And so this is also what AR Foundation allows you to do. You can quickly check and take advantage of features if they're supported by the hardware, supported by the API. Then you can take advantage of them, and if they're not available, then you can just have a fallback sort of scenario where you just don't use like the light estimation, for example, of the environment. And if it's not available, then you fake it. But that's the idea of AR Foundation. So that really allows you to find about the hardware that you have in hand, but without having to know what the hardware is. It's a bit like the abstraction principles of interfaces, for example, or protocols, where you don't really want to know what something is. You want to know what it's capable of, and that's the idea of AR Foundation. So the latest features that we brought in AR Foundation on top of plane detection, as well as object recognition as well, so we can recognize 3D objects, 2D images as well. In the latest features include meshing, so that we can automatically mesh the environment, especially if you have a hardware that is capable, such as the latest iPad with a LiDAR. Then that allows you to create a 3D mesh of the environment, which is very handy for the static environments, because then you can mesh the environment, and then you can be like very accurate, snap onto the objects, or even assign textures or do occlusion as well, so that the real life can, or the real world can hide objects that are in the virtual world. There's also depth. So depth works in somehow in a similar way, or offers similar features. It provides you with a depth map, and that works very well for dynamic environments. So that if the world is constantly changing, then you don't want to spend too much power onto trying to mesh it. Then you just take that 2D or depth map and use it to do the occlusion. And the latest feature also allows better support for the universal render pipeline. Unity offers different render pipelines. So Andy was touching on this earlier, as naming HDRP, which stands for High Definition Render Pipeline. We used to have only one render pipeline in Unity, and it scales. It used to, like pretty much every other video game engine, it used to try to stretch across all the platforms. And obviously, what you can do with a PS5 is not the same as what you can do with a 5-year-old smartphone. So instead of trying to stretch that much, what we did is that we decided to open the render pipeline for good, so that people could actually customize them. And we provide two render pipelines. One is called the High Definition Render Pipeline. It's to take advantage of the latest features that you have on PCs and on next generation or current generation consoles, as they're just out. So if you want to do ray tracing and take advantage of the latest GPU to do like very highly realistic rendering, then that's HDRP. If you want something that scales across all platforms and consumes the least power, especially on handheld devices, it's not so much about the capability of the device, it's about the battery life. Because you can run something that renders like beautifully on an iPhone, it's just that it's going to run for 5 minutes until the battery goes out. So URP is the universal render pipeline, and we've got better support now to allow integration between the real world and the 3D world rendering using URP. So the best way to work with AR Foundation is to try it out for yourself. We actually have amazing samples, and it's actually I think it goes back to what I was saying earlier. The learning curve of Unity is really the smoothest when you want to get into Unity and learn about whether you've never done C# before, or you've never done 3D before. We've got tons of samples and also learning material like courseware and tutorials available. Because of the COVID-19 situation back in last June, we decided to actually make our learning premium platform available for free to everyone. And at some point, we just decided to leave it for free. So it was something that was not to stay, and then it's just going to remain free. So there's lots of different tutorials, but the best way to learn about AR Foundation is to look at the samples. It's all hosted on GitHub. That's also part of the Unity. A lot of it is open source, which means that there's a lot that you can just take the source and modify it as well at will. And you can also contribute to it. So if you want to add a feature and or contribute like a bug fix or something, then there's a very strong community, and it's also what makes the power of Unity. So with that being said, I would also want to touch on Mars. So Mars, it's a cool code name. Sounds like very spacey. It's actually a mixed and augmented reality studio. The idea of Mars is that we understand somehow, like we appreciate what people want to do in the field of AR and MR and VR, and we understand that a lot of it is yet to be discovered, yet to be defined. And like I was saying earlier, it really is like a recipe. So it's not something that you can just get out of the box and say, oh yes, I'm going to AR this, or I'm going to MR that. It really is something that you want to carefully design and craft, and then it needs a new sets of tools so that you can iterate faster. So beyond what you may do with MR or AR, we understand that you need to work with real world data, and that there's nothing like that being inside of a development environment such as Unity Editor and Visual Studio. You're in front of your computer, but you know that what you are designing and what you are willing to test relies on a hardware that you need to deploy to, and it relies on real world data that you need to test against. So it makes it very difficult to test, right? It's easy for us to be inside of Unity Editor and to plug like a PlayStation controller and get to play like a PlayStation game, because somehow we have a screen, we have a controller, so we can make your computer look like it's a PlayStation 5. But when it comes to create a mixed reality application, then it's kind of difficult to help you take your computer and make it feel like it's a HoloLens or a MR headset, right? You can't just take your computer and wear it like if it were. So we wanted to make it that you can work with the real world data inside of the editor, so that it feels like you are experimenting the experience that you are actually crafting. So that's a bit of an inception sort of moment, where with Mars, what we're going to do is that we are actually going to let you try out and test your AR or MR in VR or in a 3D environment. So you're going to be able to use a 3D environment as if it were a real world environment and test your MR or AR experience against that. Another thing also is that we understand that when you do something like Pokemon Go or anything that involves AR and the MR, you also have a lot of unknowns, right? It's actually personally, it's one of the reasons that I love working on known hardware, such as iOS or gaming consoles, because you know exactly what you're going to be dealing with. But when you do AR, then people are going to be playing in their own living room, which will not look like, which will not be the same as the living room that you tested your experience against. And so this is why also Mars allows to author content that adapts to different situations. So that they call this fuzzy placement. The idea is that you can give rules and tolerance around what you're looking for in the environment. So that instead of saying, I want a flat surface that is this size, you can say, I want a flat surface that is about that size. It's okay if it's a bit smaller. It's okay if it's a bit bigger, but it can be too big or it can be too small, because that's about the size I need to fit this object. So if the plane that you find, if the table you find is too small, then the object will look ridiculously big on it. But if the area is too small, then the object won't fit and will be somehow like appear like it's going through the walls or something. So that's the idea. So Mars is a complete tool set that comes on top of Unity and brings everything in one place to author MR and AR experiences. It comes with a simulated device view, so it's you can think of it as a device simulator, but instead of having a device simulator next to Xcode or next to Android Studio, then you have a device simulator right into the Unity editor where you can preview your 3D interactions. And then there's the simulated environments. We actually provide a few of those environments. This is 3D data with the real world information so that you can really test your experience against that environment. So let me just let me just skip that slide. Basically, we have that fuzzy authoring that I was talking about earlier. That's the idea. You can see that you can position objects based on different surfaces, and that's the video that I want to show. So the idea is that you can simulate, instead of having to build, deploy, test, build, deploy, and test all the time, where you are in a hypothetical world, you're defining your constraints and everything, and then you have to build and deploy on the phone, go and test against the real world. There, you can actually test without building, without deploying. You can test against the real world. So especially in a COVID-19 situation, if I had to craft, say, an experience that is meant to work around the Eiffel Tower or Big Ben or something like that, then I could easily just get that model and make it available inside of Mars so that I could test my experience against the real world conditions without leaving my home, which is not a good sign, I guess, because I want to leave my home at some point. So that's the whole idea of Mars, and it allows you also, like this is another example of what Mars allows you to do, is to really have like this content awareness inside of your application, so that your application can really react to different things that it finds around. Same thing with Mars, it's a complete abstract and layer. So it's actually based on top of the AR foundation. So the same thing applies to Unity Mars. You work with Mars for Oculus, ARKit, ARCore, same thing. And we also have some specific hardware providers to be able to craft very unique experiences around what you have, like in the camera or in different kind of inputs. So I see that we are running a bit out of time, so I'm probably going to just dash through a few of the slides. Interact is another solution available at Unity that takes advantage of VR. So, and that allows you to create learning and training and testing experiences, taking advantage of 3D. So likewise, pretty much like the other solutions that you saw before, we're doing our best to find the workflow that most people have and make it generic and super efficient. So Interact allows you to import your CAD files and bring in all the different VR systems. It features a physics engine, and it's especially, I guess, a few examples will make more more sense, but the idea is to help you appreciate the ergonomics of the solution. So it contains like a full body inverse kinematic system that allows you to preview, or prevent actually traumas that you may have when you operate. Like, so for example, if you were trying to lift a very heavy weight in real life or in the virtual world, this would actually tell you that this is a very bad position and that you need to rework your work environment, maybe rework the height of the dashboard, for example, or rework the tools so that you can make a better experience in the end. So that's a quick video that shows a few things.
I'd mute it. But yeah, one of the advantages of using something like Interact is really just to the physics side of it just really does enable you to build your environment and interact with it as if it was real and as if it was built. So the demo you're watching here is about working out how pipe and nozzles need to fit together precisely to ensure that you get the proper flow of it. So rather than testing that in real life, you can build these models and the physics will act as if it was real life, which is great. The other example on there with the model was looking at L'Oreal and how their teams are working within a factory to make sure that they're able to safely operate equipment, safely move around within it, and avoid things like bad posture or overloading your joints when you're doing work. So it isn't just about physical space, it's also about how you, I mean, the name is Interact, but it is literally about how you interact with that space. So if you want to move models around within a warehouse, or if you want to reorganize your workflow, put your CAD models through Interact and you can see where this equipment will fit, how this equipment will fit within the space that you've got, or how an individual will be able to work within that environment that you've built.
And last but not least, Forma. So if you've seen the announcement, actually Forma just is released today. There's going to be an event later today. Basically, Forma is it's a complete suite to provide marketing everything they need from the engineering and manufacturing departments. So, like Andy was showing earlier, we want to think of the whole pipeline from, the creation or the design or the ideation of something, then the creation or the manufacturing, the building of something, and then the operation. And this life cycle is pretty much true with everything. And the way that you also present and not just sell, but somehow like selling as not just selling in the mean of financial transaction, but also selling, like you could also just be selling an idea and trying to get approval for some things, for some project that you want to try out. The idea is that we want to provide you with the tools that allows you to create a slick presentation scheme that allows anyone to understand your thinking process and all the different iterations and steps that you went through, and all the different combinations that you can get out of something. So this revolves around 3 steps: import, create, and publish. So import is all about how do you import a model inside of Unity, and we know that so far we've made it like easier and easier and easier, working around all the optimization process that it takes, and like making it easier, but still it used to take some specific knowledge that is a bit off the expected knowledge of someone who wants to use a solution like this one. So Forma offers the ability to import all the data, but not just of one model, but a model and all its variations. So a model plus all its animation, all the options, all the different materials that objects can receive. So if you think of a car, for example, That would be all the different options for the dashboard, for the bumpers, for the rims and everything, plus all the different car paints and leather colors and all that, and keep like complete configurations around that. Then create as in a mean of authoring your presentation or your self-presented configurator, where you can provide different environments for the car that you want to show. Of course, we're showing a car, but the idea is that this applies to everything, and not just like appealing 3D models, but this can also be like very technical models, or could even be used like in architecture, for example, to present like buildings or things like that. And so this is where you author all the different combinations. So basically, you're creating the tree of combinations of possible like viable possibilities that you want people to be able to do inside of your final configurator. And then you publish, and when you publish, this is what it looks like. And of course, everything is customizable. So the user interface, like how you present things, the different camera angles to look at the different body parts, the animation, all of that is fully customizable. But the idea is that this is something that you can then use and reuse for different purposes, such as rendering high quality images, if you want to put all of that into a brochure, if you want to make this available on a website so that people can just play with a web page. All of that is then available. So the idea is to bring everything together in one place. Obviously, we want this place to be Unity, and the idea is then to bring all the data into this place and make all the necessary features and parameterization that you can publish to everything. So that's the idea. You could publish to WebGL, cloud streaming. We also have solutions if you want to make super highly realistic 3D rendering that could only be done on a very high-end PC. But if you want to make this available to everyone who either has like a very low-end PC or just a very old smartphone, we also have solutions to do offline or cloud rendering, so that the rendering happens on a GPU in the cloud, and then only the image is streamed. But the idea is that pretty much like with Unity, you can publish everywhere out of this. So basically, the idea is then to save time and have something that you can extend and customize as well. You can create your own content. So if you want to create your own 3D environment, then it's all still based in Unity. So you can hire a Unity developer if you want to extend it. If you can hire a 3D artist if you want to make some more content, and then you can easily publish to the major channels that you would want to publish to. So I guess we still made it in time. We've got 1 minute for Q&A. That's less than we expected.
I think we have a little longer for Q&A, I think.
Okay, good.
Yeah, no, guys, you've got some time. Thank you so much. This was a really insightful talk. I have honestly learned so much myself. I was really looking forward to this, and yeah, it just goes to show how engineering can be super creative, and how important it is to have that influence. So yeah, we've got time for some questions if you're up for it. There's quite a few in the chat, so I think I'll go through them and pick some out.
Cool.
So one of the ones is, how many years will it take for the whole world to use AR technology? So I suppose, how many years until it's really widely accessible and used day to day?
That is a great question. I suppose there's a couple of ways of looking at that. So we're seeing like devices like the iPhone now with their LiDAR scanner and their ability to run AR, VR apps natively. Like, we are going to be led, I would assume, by consumer technology growth. So I would say probably we're seeing some more use cases for it at the moment. I would guess we're still probably 10 years away from it being a ubiquitous technology. Fred, I don't know if you think it's going to be any quicker than that. I still think we're a little way off. I think we need to get better wearables, better better ways of interacting with the technology rather than just through phones, or through iPads at the moment. I think that'll be crack that will speed up adoption.
Yeah, for sure.
Yeah, I think there's probably it's not just in the hands of a few. There's obviously the hardware that needs to be able to deliver like a very acceptable experience. Like VR headsets have been around for decades now. I remember testing my first VR headset in the 90s. Like the resolution was like super low, and you would enjoy playing a game, but you could certainly not use it for work for anything. So there's the hardware side. Then there's also the market side, and the market, one drives, it's a bit of a chicken or egg sort of thing, where the market will only adopt something when there's enough offering. Like for example, if you take the PlayStation VR headset, I think that it really the sales really went up when they featured that video game Beat Saber, where it's basically it's Star Wars, Fruit Ninja, and Guitar Hero thrown into a mixer, and you get an amazing game experience out of it. It's made with Unity, by the way, and so when you have such offering, this drives the sales. When it drives the sales, then manufacturers will be willing to put more engineering into doing something, and that becomes like a virtuous circle. So I think that probably this is in the hands of designers and developers to come up with unique ideas, not just gamification sort of thing, or ARification. That's a horrible word that I just made up. But where I think you don't need too much to think of what could be AR used for, but rather think of all the different kind of problems that you may face in an industry, and just think, hey, wait a moment, if I had AR, could this solve, could this be a solution to this problem? If not, then you just get to something else. But if it does, then you want to search. But not trying to get to apply AR or MR to everything, but really to think that makes sense.
Yeah, definitely. And I guess that sort of leads on to a question I had. So is the development of PC computers able to keep up with the demand and potential of XR technology, or do you think it's going to get to that point where the world of XR is just it's being held back by sort of capabilities of laptops and PCs?
Andy?
Well, I have a crack. I mean, that's a great question, right? So we're in that kind of almost chicken and egg. So we will develop solutions that can run on existing technology to keep that kind of the resource hunger down. You will always get those developments that push stuff forward. So I want to confidently say computers will keep track with the need, because they kind of have to. And if you look at the power of devices now versus, I mean, I know it's Moore's law, whatever, but we're talking about stuff now which would have been impossible 5-10 years ago. So I'm quietly confident that we will keep on top of it, but that is based purely on on a hope rather than a confident opinion, I think.
Yeah, it's really interesting. I guess we'll just have to see with that one. But yeah. So another question, what do you think of Vertilis and their VR interconnectivity and platform?
I don't know Vertilis.
Oh, they're based in Manchester. They are unlock your VR superpowers, connect all your digital assets together and put them in the hands of your entire organization. Yeah, Yeah, they bring connected visualization into every conversation. Yeah, so perhaps Mohammed could expand on that in the chat, but yeah, we can move on to a different question.
Yeah, I mean, I mean, we're always up for learning about new people and new solutions and stuff, but yeah, it's not one I've heard of.
Yeah, sure thing. No, I mean, there's so many, aren't there?
I like that timelines. I like your VR superpowers.
Yeah.
All right, so we will go to another question. Could you elaborate on how the workflow works for AR, AI, and simulations?
Sure. So AR, AI and simulation. So AI and simulations are somehow like tightly integrated with each other. I know that you know, sometimes with simulation we think of like physics simulation, like what would happen if I put a 500-kilogram object onto that conveyor belt? Would it jam or would it break? Would it tear up? So that's something that we've got solutions for. Actually, that's another solution that's called perspective, that allows you to preview what would happen if you put you know, in real world conditions, mechanical objects altogether. Then there's simulation in the sense of AI, and in AI there's also been a lot of misunderstanding those last few years around AI, because and still, like when you read the newspaper, you know, like the general newspaper, when they talk about AI, very often they talk about algorithms, which is not the same as machine learning. So when it comes to machine learning, we've got that solution or tech stack that Andy was showing earlier, that allows you to run simulations or using machine learning agents. So you can train agents inside of Unity to get them to learn about what it is they want to do. So this can be good for autonomous vehicles, to train an AI for an autonomous vehicle. It can also be good to train a video game player. For example, if you want to have like an AI to feature an enemy in a video game, a lot of video game developers actually are looking at machine learning to, instead of having like, you know, algorithm based AI, which usually is like, you know, just too good or not good enough to beat everyone. So that's the idea, and that is slightly different from simulations, because the idea of simulation is like to be able to run a lot of tests at a higher speed or pace than you could in real life. Like saying, for example, when you want to train an autonomous vehicle AI, then if you do this with a real car, not only that would be like super dangerous at on the first miles, but it would also take, you know, it usually takes like hundreds of thousands of miles before the car can actually get to learn how to drive in the environment. The idea there is that you can actually accelerate and drive those miles at a higher speed than just real time. So it's actually faster than real time, and so you can have those hundreds of thousands of miles being driven in a couple of days.
It's really interesting. Yeah, go for it, Andy.
We're actually running, I think it's tomorrow, it'll be tomorrow evening, our time. There's the Unity AI Summit. So it's free to register. I think I've just put the link in the chat. So for those of you that are interested in how we use AI to develop simulations and how we use AI to develop better understandings of programs, there's actually coincidentally, there's a whole conference tomorrow on that tomorrow. So if you'd like to learn more, you can.
That's great. Thanks for putting that in the chat. Now we definitely check that out. Yeah, so we've got a question from Alexis. What was the route to your careers in AR and using Unity? Were you both self-trained or trained on the job?
So I'll go because mine will be shorter. So so I studied sociology and social policy at Leeds. So a completely natural path into selling technology. When I left uni, I ended up working in digital marketing and technology. So I've been around. I've been around that space for a long, long time. And Brighton is a digital hub. Unity have an office in Brighton, and just from working with various people and networking, it became like everyone was just like, you need to learn what Unity are doing. You need to understand what they're playing at, and Unity is free on a personal license. So you can get it, you can play around with it, you can teach yourself how to do some of the technology. You can, and especially now with Learn Premium being free as well, it's a great time to get playing around with it. We will focus on depending on what role you're looking for. Just having a working knowledge of C# is going to be invaluable to you. And then from there, learning Unity, playing around with the tools is a great way in. But for me personally, I didn't even start playing around with it until maybe 18 months ago. So my background has all been digital marketing, actually, and other digital tech. So I worked for a social media listing company, and that had a huge element of NLP and machine learning within there, which is a good transferable skill.
Yeah, great. It's a really good journey. How about you, Fred?
Well, I'd say that I don't like saying that I'm self-taught, because I consider that, you know, even when you read a book, somehow you learn from someone. You just learn from someone who didn't spend time with you. They just spent time writing a book that you read and learn from. So I learned a lot on the job, and mostly with people. And that's probably what Unity brings the best, is that, you know, you have the ability to test and to test the full run, just not, you know, take some technology and do something and then be stuck with it because you cannot publish, or that you're you know, we live in days where, like, you know, you can be like, you know, 12 years old, you know, playing with Unity and publishing a game yourself. Not in every country though, but the idea is that you can not just practice on the tech side of things, but also practice on the business side of things as well, because you can, you know, promote your idea and go the full run. So that's probably the best way to do it. You know, just get cracking with Unity, the learning page, give yourself some, you know, fair objectives as to what you can do within the next few months. You know, so not something too crazy. Don't get into saying, oh yeah, I'll do an RPG like a AAA MMO or something like that. But, you know, like small steps, and the learning curve is fairly smooth.
Yeah, I've just posted a link to the Learn pages for everybody. There's also, if you want to learn how to make a game in Unity, there is the Lego micro game that we released maybe a month ago. Build your own Lego platformer using Unity as a training tool. It's good fun. There's also just this week a Christmas plugin pack, so you can play around with that as well.
Yeah.
That's really cool. Thanks for that. No, we'll save those links, get them sent out to you guys as well. That's a really useful resource to know about. So another question that we've had, how does Unity ensure compatibility between applications run on VR headsets such as HTC Vive and Oculus, and an iOS smartphone, which wouldn't have such high-end controllers?
We have got but I think enormous team is probably the nicest way of putting it. So we are just over 4,000 people. I would say 2/3 of that are engineers and developers. Fred, do you reckon that's about right?
Yeah.
Ish. So an enormous part of the focus is when we develop a new stream or a new product or a new approach is to make sure that we've got that compatibility. We don't certify stuff until we're happy that it works. So you take something like HoloLens 2, there was an enormous amount of work to make sure that everything we could do works on the new systems. Going the other way, it's the same as any technology provider. We have to draw a line somewhere with some of the older technology, but for the most part, it's just making sure that the technology is stable enough to run it. I mean, if we can't run it, we'll be very clear. I think most developers are will know that you can't run high-end stuff on low-end technology. That's unfortunately just the way it is. but writing in the language that we use and the way that we do it means that we're trying to keep longevity in there as much as we can. There'll always be limits, unfortunately. I'm not sure if that answers the question, but
No,
the approach is big team to try and support it.
For sure, that's really great.
To that point, also know that it's not because you can create one project and publish it to all platforms that you cannot easily make branches as well. So you can also have one project and switch between different platforms, but you can also have within one project have like different variants of everything. So you can have different variants of the models, the textures. So you can have like lower resolution of your textures, for example, for low-end devices, higher higher resolution 3D models for some other platforms. You can also branch the code. So you, for example, you may have like something that is like physics or AI, something that really takes a lot of performance. You may only run this if you are on a specific platform, whether it's because of the performances or because of the compatibility. So you can always, you can easily maintain one project on Unity with different branches and then publish to the different platforms that way.
That's great to hear. Thank you. Yeah, I'm just going to ask one more question, but before I do that, as you can all see that I've put in some links into the chat. So we have our feedback form. We want to make sure that these events stay free, but what we really do appreciate is if you could take a minute just to fill out a really simple feedback form, and you can join our mailing list through that as well to keep updated with the latest of our events. Also, please do sign up for a certificate attendance. It will be in your inbox within a couple of minutes. So yeah, that's just proof that you've joined us today. And then yeah, our GoFundMe page. So because we are currently unofficial with the University Union, we are unfunded, so we have to find funds for ourselves wherever possible. And one of these places is through our GoFundMe page. So we would really, really appreciate anything just to help us be able to afford platform memberships. And eventually we would love to be able to run courses next time for you guys, where we will, maybe get some people in or teach them ourselves. And, these things can cost sometimes. So we really appreciate anything that you might want to give to us. So yeah, the links are in the chat. Please do take a few minutes to go through them. And I'm just going to ask this last question. It's from Christopus. Can I make a VR headset with a Raspberry Pi or Arduino and play Unity VR games?
I'm so glad you picked it, because I was going to answer it anyway.
Good question.
Yeah, it's a very good question. I would actually I would love to know. I guess if in a way we support most of the API for VR, including OpenVR. So there might be a way there. If you do try, and please do, please let us know what you find about.
Yeah,
I'm going to post that question in one of our dev chat channels on Slack to see if I can get an answer for you guys. And if I get an answer, I'll forward it back to the team and they can send it on to you. But yeah,
we can save it for our next Hack Week.
Yeah,
I'm sure we'll have some Arduino geeks to help us in that.
That would be great. No, please do ask that question. I think it's a great question, and I think this technology hasn't been fully explored in areas, and people are still discovering things. So yeah, why not give it a go? So yeah, I think that puts an end to our event. I just want to say a massive thank you to Andy and Fred for joining us. I was about to say coming all this way, but it's online. It's not that sort of thing anymore. So yeah, a massive thank you to you both. It's been a really interesting talk. I've learned a lot. I really hope everyone else has too. Yeah, so massive thank you. And this will be our last event until the new year. So we will see you then. And in the meantime, have a great Christmas and a happy new year.
Brilliant. Thanks again, guys.
Oh, thanks very much.
Thanks.
Bye-bye.
Bye.
Cheers.